Hello, ladies and gents. Sanbonani Dumelang. Welcome back to my YouTube channel. I hope you enjoyed the last episode of the algebra. We also gonna focus on algebra on this lesson, but specifically for inequalities, and then secondly on simultaneous equation, and lastly on nature of the roots. I think from here on we'll be done with algebra unit. We'll focus on the next chapter. I will also maybe give you the heads up on the next chapter we're gonna focus on. So let's see, without further wasting time, let's go to number 1, inequality. Inequalities. So the quadratic inequalities, they are all derived from the basic quadratic or the standard quadratic equation that we know. That includes ax squared plus bx plus c. But now we're not gonna equate the equation to 0, because in simpler terms, quadratic inequalities is a function whose degree is 2, and whereby the y is not always exactly equal to the function. So while they mean it's not exactly equal to the function, they say y equals to ax squared plus bx plus c, meaning this is not always the case. Then in that instance, we're not gonna always have exactly the one value of y or one value of x. We're just gonna look at the spectrum. What's the name? The spectrum. Yes, whereby we have all the values of x up until to this degree. So let's look. And then the standard forms of inequalities, we have 4 types of inequalities. We have greater than, we also have less than, we have greater than and equals to, or greater than or equals to. Yes, the proper way of saying it is greater than or less than. And then when it's facing on the right hand side is greater than or equal to. When it's facing on the left hand side is less than or equal to. So these are 4 basic signs of standard signs we're gonna focus on dealing with these inequalities. And I also need you guys to note these things. They are very important. How do we change the sign of the inequality? That's the question. This is the standard. You must know this by heart. So the inequality sign changes if only if we multiply an inequality. Let me not write the whole thing. If we multiply an inequality by a negative, let's say we multiply by -1, depends, but when you multiply the inequality sign by a negative sign, then the sign changes. That's one. 2 if we divide by a negative value, the inequality sign changes. If before it was facing on the right, it was greater than, therefore it's gonna be less than. If it was less than, therefore it's gonna be greater than, vice versa. Lastly, when you transpose a number, and then let's say we are not necessarily solving for x, but we are solving the inequality quadratic expression, quadratic inequality expression, and then you get to, let's say you get to notice that, okay, x plus 3 is less than 0, and then you are going to the last step of saying x, then you have to transpose 3 that side, because you want to know the values of x in that inequality expression. It's gonna be x plus 3 less than 0, and then you transpose it. It's gonna give you something like minus 3 this side. But now you need to take this inequality sign into consideration. Remember, I said when you transpose a number and then it becomes a negative, then the inequality sign changes. It's no longer going to be less than, but it's going to be greater than. But let's say it was x minus 3 less than 0. Then you transpose this 3, it's going to be x less than 3. You don't have to change the inequality sign. These 3 things are very, very, very important. You need to have them in your head. Then when you multiply or divide the inequality by a negative value or a negative sign, it changes the inequality sign. And when you transpose a number while we are solving for x in that inequality expression, and that number becomes negative, then you change the inequality sign. Very, very important. But if you are multiplying and dividing with positive numbers, you don't have to change the inequality sign. And if you are transposing the number while solving for x, and that number becomes positive, then you don't have to change the inequality sign. Very, very important, guys. Let's take this for an example. You have x squared is less than 25. Then they say solve for x. Okay. What do we have to do? Remember, you are solving for x. You must transpose everything to the left hand side so that you can be able to solve for x. So we are saying x squared, transpose this one to the other side, is going to be minus 25 is less than 0. Good. This is the standard form that we know when we are solving for x form. The very, very standard, that the very, very foundation standard that you know by saying x squared plus bx plus c, they must give you 0. But in this instance, we are dealing with inequality signs. So we are solving for x here. Oh, difference of 2 squares, but not of 2 squares. Oh, okay. We are saying x squared, not x squared, x less than 0. Okay, 20 minus 25, it's gonna go, it's 5, yes, and then we have minus, gonna be plus and minus here. And then we are saying x plus 5 is less than 0, or x minus 5, they are all less than 0. And then look at this. X is, okay, before we can focus on the sign, what's going to happen with this 5 when you transpose it to the other side? It's going to be negative 5. And then remember, when you transpose the number and it becomes negative, you change the sign of this inequality. It's no longer going to be less than, but greater than, minus 5. Or x, and then when you transpose this to the other side, you are getting a plus 5. Then the sign is not changing because the number is positive. Then it's less than 5. Another thing that you need to note, how to interpret this answer on your Cartesian plane or on the number line. Very important, because they might ask you, draw this equation or solve this equation and then represent it on the number line, or present it on the number line. So remember, on this quadratic inequalities, how can I say, we are looking at the degrees, or we are looking at the second degree expression in x, meaning it's not only one answer to that x. It gives us a range of those x numbers that we can play with, or that the graph exists in. So meaning we can have any x that is greater than, looking at this one, that is greater than minus 5, and any x that is less than 5. Therefore, we can say x, we can represent it by both signs, on the left and on the right. We are saying x is greater and x is less than. So meaning, looking at this, that's saying x is greater than minus 5, meaning x is greater than minus 5, but also x is less than 5. And here we can also say x is less than 5. Good. Let's go to the number line. So this is the number line. You can see here and here. This is, you can say 0 point. When you are going or counting to the left, that direction, we are having 1, 2, 3, 4, 5 here. It's minus 5. We are having 1, 2, 3, 4, 5 here, positive 5. Minus, go in that direction, plus. Meaning that we can have any x that is from not from 5. Look at this, not from 5. They are not saying greater or equals to, they are only saying greater than. So you can have any number from 4.9, let's say 4.99, because they're not saying anything about 5, going all the way to 5. This is how you represent your answer, or this is how you present or draw your answer on the number line. So meaning it can be any numbers on this graph here, all the x's in this. Oh, that's good. Let's take another example here. X plus 3 into x minus 5 less than or equals to minus 12. Step number 1. You need this thing to be on a standard form of ax squared plus bx plus c is less than or equals to 0. This is what you need. Let's go. By looking at this, we need to multiply these things out. So it's gonna be x squared minus 5x plus 3x minus 15 is less than or equals to minus 12. X squared, and then there's like terms. 3 minus 5 is gonna be minus 2x minus 15. Transpose this one to the other side so that you can add them with this constant. It's gonna be plus 12 is less than or equals to 0. And x squared minus 2x minus 15 plus 12 is minus 3 less than or equals to 0. Then let's go for the factors. 2 brackets. This is a quadratic equation. X, the factors of 3 is 3 and 1. But when you add or minus them, they must give you the middle term, which is 2. And then remember, the sign of the middle term goes to the bigger number on these factors, meaning the bigger number takes the sign of the middle term. The bigger number here is 3, then it's going to be minus. This side is going to be plus, because we need to multiply this to give minus 3. Good. Then is x plus 1 on one side less than or equals to 0, or x minus 3 on one side. And then we are solving for x. For x, this side is x. When you transpose plus 1 to the other side here, it's going to be minus 1. Remember, the sign of this inequality changes because the number here became negative. Then it's going to be x greater than or equals to minus 1, or x, you transpose this one, this side, it becomes positive, then the sign of this inequality sign remains the same. Okay, now we see that x is greater than or equals to minus 1, or x is less than or equals to 3. Then you need to present this thing on the number line or on the graph. Then we are saying x is greater than or equals to, x is less than or equals to. X is greater than or equals to 1, meaning x is greater than or equals to minus 1. And then x again is less than or equals to 3. X is less than or equals to 3. go into the number line. Draw the number line. You have 1, 2, 3, 1, 2, 3. This is your 0 point. And then you have -3 to the left, -2, -1, 1, 2, 3 to the right. And then looking at this, they say x is greater than or equals to 1, meaning we're gonna draw our first point here because this is -1. Our second point to be at 3. This is it. Because they are saying x is greater or equals to, meaning it includes 1. They are also saying x is less than or equals to 3, meaning you have to include 3 as well. And we are connecting both of them. When we are saying less than, we can't go to the left. If we are going that direction, it's not less than anymore, it's greater than. No, I'm not making sense. Let me repeat. If we are counting to the left from this -1 to the left, this is less than, because you keep going further and further and further from the positive numbers, meaning it's less than. But when you are saying greater, meaning you move to the right. But when you are saying greater, you move, or when you say less than, you move to the left. Remember that. When it's less than, we move to the left. When it's greater than, we move to the right. Good. So from here we are connecting -1 and 3. So all your values that are between, including -1 and +3, they are good. So you can also draw the graph. Let me use this. You can also draw the graph by saying you can have all the numbers in here. That's good. That's good. That's good. So guys, I hope you will have more questions for you to practice, because I think I'm against time. Let me quickly jump to the next subtopic called, let me change, number 2, simultaneous equations. So guys and ladies, please let me know if you need me to explain further and further on, or to explain for you, if you need any clarity on these inequalities. Please let me know in the comment section, then I will I'll make sure that I explain more on this subtopic of quadratic inequalities. Let's jump to simultaneous equations. Simultaneous equations are very, very easy. These are just easy marks in your exam and in your test, because you'll be given two equations that they both have two variables. They have x and they have y. And your way of doing it, it's simple. It's very, very, very simple. And they are both quadratic equations, and not both. They can give you a linear equation and quadratic equation for you to solve it. using the simultaneous methods. So I'm just gonna go straight to the point. You'll be given y and x as variables on both equations, and they won't give you a straight away equations. They will just mix them up so that you get confused, but just remember these steps. You'll be given two equations. You just have to name them. Like you'll be given, let's say, y plus 2x minus 2 equals to 0, and 2x squared plus y squared plus 3yx. No, not plus here, equals to, so that it becomes more interesting. So we'll be given this. They're saying solve for x using, they won't even tell you they're using simultaneous form and simultaneous methods. They will say solve for x. Then you know when you have two equations and they have mixed variables, then it must click in your mind that, oh, okay, this is a simultaneous equation. So step number one, what you need to do is to say, okay, we have this equation equals to, then you name it equation 1, and then 2x squared plus y squared equals to 3yx. Then you name equation 2. From this, you derive your own equation by making one of the unknown subject of the formula. And the easiest one, please take the linear one to make the subject of the formula. Don't take the one with the x squared, the one that raised to the power of squared or cubed. No, don't take that one. Please take the linear one. In this instance, the linear equation is this one. There are no x squared, y squared on it. Just simple. Make it the subject of the formula. And then name that one equation number 3. So we are saying y, we leave y on the left hand side and we transpose everything on the right hand side. Y equals to, when you transpose this 2, it's going to be 2x is going to be minus 2x plus 2. So the sign of this one's changes. Let me make it red so that you can see the difference. This is minus, this is plus. Yes. Then you name this equation number 3. Good. The following step, you are saying, okay, since while I have y equals to minus 2x plus 2, I can safely say, okay, let me take this and substitute it in the equation number 2, this one. Because now it's easy. You can safely do that. Therefore, we substitute equation 3 into 2. My equation 2 is 2x squared plus y squared equals to 3yx. Whenever you see y, you substitute the whole formula into it. Because we are saying y equals to minus 2x plus 2. Whenever you see y here, you substitute minus 2x plus 2. Let's go. That is 2x squared plus, this is y raised to the power of 2 into brackets, minus 2x plus 2 all squared equals to 3 into minus 2x plus 2 multiplied by x. 2x squared plus remember these are raised to the power of 2, so it's gonna be simple for you to just split it into 2 brackets so that you don't make mistakes. 3 into minus 2x plus 2x. Yes, now we can multiply these things out. This multiply by that multiply by this multiply by that multiply by that. So it's 4x squared minus 4x plus 4 equals to 3 into minus 2x squared plus 2x. So like terms, this 2 is 2x squared, 4x squared, so it gives you 6x squared minus 4x minus 4x gives you minus 8x plus 4, and then that side you have to multiply this 3 by everything that is inside the bracket, and then you are having minus 6x squared plus 6x. Then you have to transpose everything again to the left so that the equation can be equals to 0. So it's 6x squared minus 8x plus 4. Then transpose this to the other side. It's gonna be plus 6x squared and then minus 6x equals to 0. 6x squared plus 6x squared is 12x squared minus this and that like terms minus 14x. Am I correct? Yes. Wait. Oh, yes. 14x plus 4 equals to 0. Now we have to solve for x. Let's see. Remember the steps that I showed you on the previous lesson, how to solve for x? We have to apply those steps here. So let's take, it's gonna be a multiplied by c, which is 12 multiplied by 4. 12 multiplied by 4 is 24, is 48. Sorry guys, I'm back guys. Sorry, I needed to attend to something. Let's move. Okay, it's 48, and then secondly we are going to check for the products of 48. It's 1 multiplied by 48, 2 multiplied by 24, 3 multiplied by, is it? Can you get 3? Let's see. Yes, 3 multiplied by 16, 4 multiplied by 12, and then we are no longer getting 5, and you can get 6 years. 6 multiplied by 8, and then 9, nope. 10 we can't, 11 we can't, 12. I think we are going back. Yes. So on these products, we have to choose the one that is suitable for us to say, okay, when we add or minus them, they must give you the middle term here. And also let us not forget the sign, which is minus 14x. And then it's 1 and 48, it can't go. 2 and 24, it can't be. 3 and 16, almost. And then 4 and 12, almost as well. 6 and 8, yes, we can use these ones. Because when you multiply 6 and 8, you get 48. And then also when you add or subtract, in this instance, we are, or depend on the sign, because you can take minus 6, minus 8, which gives us minus 14. So that's good. You can take this one. Let's go. We rewrite the middle term of minus 14 as minus 6 and minus 8. So it's 12x squared minus 6 minus 6x minus 8x plus 4 equals to 0. And then we are grouping them. So it's 12x squared minus 6x this side, and then the other side is going to be minus 8x plus 4 equals to 0. Oh yes, good. Then we are taking the common factors from this side. We have a common factor of, not only we have a constant, not a constant but coefficient, and x as well. Yes, it's gonna be 2x outside. Then we have 6x, because when you multiply these two, they give you 12x squared. Then minus 3. Then when you multiply 2x by minus 3, you get 6x. Good. And then this side, what's the common factor here? Common factor is 4. It's gonna be minus, yes. When you take this common factor, you have 4x, not 4x, I'm lying. You have 2x, because when you multiply minus 4 and 2x, they give you minus 8x. And then minus 4 out, you need to have positive 4, then you say positive, not positive but negative 1 equals to 0. And then yes, so this you can solve it. I can see from here you can even solve it, because we have 6x minus 3, and then you have 2x minus 1. This is what I said on my previous lesson, that if you have like the expressions or everything that is inside the bracket, they must be the same. So meaning what we got here must be the same as what we got this side. If they are not the same, meaning you have to apply quadratic equation, not quadratic equation but quadratic formula to solve this equation, for you to get the x's, for you to get the y values as well. So guys, let me give you this as homework. We go back to solving this equation by putting it on a quadratic formula, and then you are going to get x1 and x2, and then after getting these two x's, therefore you are going to substitute these x values on equation number, let's go back, on equation number 3 that you made the subject of the formula. Because remember, you are solving for x and you are also solving for y. So if we have the specific x's, you also need to know what's the corresponding y value of that. So y equals to minus 2x plus 2. So whenever you see x, you substitute. You're gonna have y1 by substituting minus 2, whatever value that you got when you were calculating the x1 and x2s. It's gonna be, when you substitute x1, whatever value that you got, maybe 1 or 2 or 2 point something plus 2, you must get the value. Also on the side, y equals to minus 2x plus 2, and then let's call it y2 equals to minus 2, because we are going to substitute whatever value that we got for x2 on this, and then you will have the specific number for it. And that's all for solving simultaneous equations. All you need to do is to write both simultaneous equation, and then you name them. You give them names. Whether you give them equation 1 or equation A or equation B, it's up to you. But remember, when you are making this the subject of whatever equation that you're gonna decide, okay, this is my equation that I'm going to use to make it the subject of the formula, or to introduce my third formula to it. It must be a linear equation, simple. Please don't complicate your life by choosing quadratic formula or quadratic equation to make it equation number 3. You're gonna struggle. You might get it, but you're gonna end up having fractions all to the squared, and you don't want to go there. You write both equations down. You name them equation 1, equation 2, and then the third equation is the one that you choose to make the subject of the formula. You see, you just leave y on the left and then transpose everything. Sometimes it's going to be x. That is simple for you to make it the subject of the formula, and then you name that equation number 3. The following step is substitute that equation number 3 into equation 2. Always the case, depending on which one you choose to make it the subject of the formula. If you choose equation 2 to be subject of the formula, then you're going to say, okay, substitute equation 3 into equation 1, the one that you didn't use before. And then you solve for x. When you get those x values, and then you take them, you substitute on the equation 3 to get the corresponding y values. And that's it, guys. That's it about simultaneous equation. Easy 7 marks, easy 10 marks in the back. I see that we have gone 45 minutes now. I'm not sure if I can go on to the nature of the roots. Let's see, because I need to take my time as well on this subtopic of nature of the roots, because you'll get it again when we are dealing with is it functions? Yes, I think so. More especially on parabolic functions, because remember, quadratic equation is parabola function. So let's just stop here for this lesson and just get to know how to solve simultaneous equations, how to deal with inequalities. And then from here we'll be done with algebra, guys. I think, yeah, this is your question number 1 in the exam, and it takes about good 30 marks, 25 marks. You don't want to lose such marks, guys. Easy marks. You don't have to scratch your head on these ones. Hence I'm taking my time to explain, to elaborate, to have different examples on it, so that it goes well with examples without just only explaining what's happening. And then the last lesson on this chapter will be nature of the roots. Then we'll be done. Thank you for watching, guys. I hope you enjoyed. See you on the next lesson. Bye. Please subscribe, like, and share. I nearly forgot that. Please, guys. I love you guys. Cheers. Bye.